let's get started, and thank you for coming to our session. Yeah, this is a project called Humanitext project. We are a group of 3 people. I'm Naoya Iwata from Nagoya University and also National Institute of Informatics from Japan. And there he is Iko Tanaka. She is from J.F. Berlin University, and also Jun Ogawa. He's from University of Tokyo. So we are working on the Humanitext project, which is basically human AI collaboration platform specifically for the study of ancient world and Western classics. Actually, we are specialists in Western classics in Japan. So today, our panel is divided into 2 sections. In the first section, so we and each of us takes turns in presenting our own work. And then in the latter half, maybe we might have some discussion and question and answers. Yeah. Then I start by presenting the kind of big picture, so making AI a trustworthy partner for classical scholarship. And then Iko will present the kind of Humanitext geo, which is mapping the Western world from authors in place and time toward generative encyclopedia. Lastly, June will be presenting connecting text to scholarship, rethinking reference indexes with inscription as a case study. Yeah, and we've got the project website, humanitext.ai. So if you are interested, please have access to this website and scan the QR code. Yeah, basically we are 3, but all of us will talk about the one ecosystem Humanitext project. So this is the Humanitext project website. We've got 5 at the moment, 5 web applications, and then mainly we are talking about Humanitext Antica, which is the core system. And also we've got some news and also some blog posts and so on. Please have a look. Right. Okay, so I start with my presentation. So AI Philology, which is the idea is basically machines generate, scholars verify, and verified knowledge accumulates. So this is a collaboration platform. So our project is basically based on the large language models and LLMs and AI. But the obvious problem is that large language models invent citations and answers and so on. And in classical studies, one false reference can undo an argument. So retrieval augmented generation, RAG, has largely solved that problem. But at the frontier now is harder. The web of relations between text and the disagreement scholars hold about them. So I am trying to introduce this topic to you. Yeah, here is a kind of map of relations and nodes and edges and so on. Okay, so what is the problem? So ask a plain language model for a citation, then obviously it often handles one that reads perfectly, but it does not exist. Often it happens. In most settings, that is a nuisance. In classical studies, on the other hand, it's disqualifying. So a single misattributed line can invalidate an entire argument, and the field leaves no room for a confident guess. So the first requirement of any usable system is not eloquence and not reasoning. Rather, it is that every claim can be traced back to a real passage in a real text. To meet that, and the model becomes an instrument that a scholar can actually use. And failure and fluency only makes the errors more convincing. So the main message is that don't trust the machine, but check it against the source. So this requirement is in practice now met. That is where our work already stands and where the next section begins. So grounding is solved and it is running now. So one answer to hallucination is the Humanitext Antica, which we have built in a public system in use since August 2024. So it does not ask you to trust it, it shows you the evidence behind every answer. So actually this is the kind of basic system, and anybody can use it. If you have access to it, then you can ask a question here, and then anybody can use it without any login in the system at the moment. So I will demonstrate later in the talk. So Humanitext Antiqua is a public search and dialogue engine, so RAG system for Greek and Latin classical literature, covering roughly 450 authors and 2,300 works. So you ask a question, it retrieves relevant ancient passages and answers with those passages shown beside the reply. So you can check the evidence rather than take the model's word. So in short, the system answers from text. It has actually retrieved from the corpus, not from memory. And then, but of course, it's difficult to embed ancient Greek and Latin directly into vector data. So we have devised a kind of system called context-oriented translation. So what is that? So today's model, so little ancient Greek or Latin, so embedding the original text directly gives poor search accuracy. So translating into high resource language like English is a natural fix. But a plain translation is not enough. For search, the corpus is split into chunks, so smaller chunks, and a chunk cut from its surroundings loses the thread. Its pronouns left dangling. So our method, context-oriented translation, COT, translates each chunk with its context result. The pronouns made explicit, the author, work, and the theme folded back in. So it outperforms a plain English translation, so specialist English, even specialist English translation. So every chunk stands on its own, and the search matches on what the passage actually means. So you can see what I mean. For example, plain translation is like if it's separated into smaller chunks in this ways, and so he concludes that it is present in them, not by nature, nor by teaching, by a divine gift. So on its own, it's hard to understand what this sentence means. But context-oriented translation modifies in this way. For example, Socrates in Plato's Meno on whether virtue can be taught, which is a topic, and so Socrates concludes that virtue is present in good men, not by nature, nor by teaching, by a divine gift. So in this way, each chunk stands on its own. And then Humanitext Reader, which is another web platform. So Humanitext Reader is a public environment for reading the texts themselves with translation shown in parallel. It already carries a community layer, so readers can comment on the passage and propose corrections to the text. People are curating and improving the edition together, which makes Reader in effect a first collaborative platform already in use. So this is a Humanitext Reader. Basically, AI translates original Greek and Latin, and then of course there are some mistakes. That's why we're trying to ask or let users make comments or make modifications on the machine translated translations. Right. So then the join from a search result straight into the text. The two systems, Antiqua and Reader, are interrelated. So search in Antiqua, click any source it cites, and arrive at exactly that passage in Reader. So this works because the unit Antiqua searches and the unit Reader displays the same unit. They match precisely. So retrieved result maps deterministically onto a place in the reading text. Okay. So I will show you, demonstrate. Yeah, so this is a new version of an interface, so that this, which is not yet in place in public, but I just try to demonstrate. If you ask a question, for example, how does Plato criticize democracy? Now send the query, and then now retrieving the text. On the right-hand side, you can see all the source texts. And then the LLM generates an answer, right? So basically, the kind of differentiating point from ChatGPT and Gemini and Claude is basically, you can see very detailed, minute citation. For example, Plato, Republic 562b-c, but of which this answer is grounded in actual source here. Then you can see the original Greek and the English summary as well, the reading view here. Basically, LLMs read this original Greek and then retrieves this passage based on this English summary, so context-oriented translation. Then if you want to have a more closer look at the text itself, then open in Reader. Then you can read the original Greek and translation in parallel English. Then actually in Reader, there are 4 translations, the Japanese translation, and not only English, but also Chinese and Korean translation. And then also you can see where this matches the original text, the highlights, the alignments in this way. And if you click this translation, you can make comments about this passage, actual passage. Then your comment is translated, automatically translated into the other 3 languages. That's why all the other users can also see what this user says in your own language. But of course, in the covering languages as well, only. So underneath, share the structure preserving foundation. So both systems, Antiqua and the Reader, rest on the same data. The most text come to us as TEI XML from the Parsec Digital Library, but some we digitize and structure ourselves with OCR, and we're expanding the corpus as well. The careful part is what happens next. So we convert these into structured JSON, chunked for AI use while preserving the text logical structure as far as possible. That's why we don't directly use TEI and XML. So the same units serve both search and reading. How that foundation is designed is the 3rd pillar, which is I will talk about in a minute. Okay. So from now on, I'm going to talk about the kind of plan, how we develop from here. So this system and this project. So the frontier is the web of relationships and the disagreement within it. So once retrieval is grounded, the real difficulty of classical studies comes into view. So it was never about finding one passage, scholarly research. It's more like about how the passages relate. And those relationships are both structured and contested. And text relate in typed directional ways. A single passage can at once quote one source, argue against the second, and echo a third, as you see from this diagram. So these are not vague related text. They are specific directional relationships. Who cites whom? Who answers whom? So flat search, flag search, returns passages that look alike. It cannot tell you that this line is a reply to that one, and so on. And also, every link is contested, so this link, right? So each relationship, the scholarly judgment that others may dispute. So commentators have argued for centuries over what the passage alludes to, or whether one author is really criticizing another. A useful representation cannot collapse this into a single answer. It has to fold the competing readings side by side. So with this is what AI philology is for. Its answer has 3 parts. So we are thinking of 3 pillars. So each with a working seed, each pointing further. For each pillar, something already runs. For each destination is larger, just a vision. The status chips mark what is built today and what is still ahead. So what we are thinking about is autonomous research agent. So this is just a vision yet, but the scholar just set question, and the agent does the searching, given research question. The agent plans and runs its own sequence of searches across the corpus, follows leads, and gathers the evidence. So a partner that extends the researcher's reach, not the one that decides what to ask. So this is already in progress. So over this Humanitext Antiqua, we are planning to introduce the kind of MCP structure. So Antiqua's search index can be exposed through MCP and connected to an agent such as Cloud Code that has a single lookup. At the moment, just if you put in a query, then the system retrieves the text. But it's rather the agentic search over the ancient corpus. The agent autonomously thinks of what to ask and then retrieves text in many ways, right? Then agent issues its own chain of queries and assembles what it finds. Over the primary sources, this is close at hand. And this is a plan. The out of copyright commentaries, we wire them in. Where commentary is in the public domain, there are many such sources in Western classics. So we plan to turn it into graph data ourselves and link it directly to the passages it discusses. So those connections are pre-built into the shared knowledge graph for everyone to search. And lastly, so modern scholarship, bring your own. For literature still in copyright, for example, PDFs and PDFs and journal articles and books and so on. So each user brings their own, upload your secondary sources much as you would to a tool like Notebook LM. The system indexes them automatically, and they join the same agentic group. The agent can even search this literature to help sharpen the question itself. Okay, so the next pillar, which is collaborative knowledge platform, which is the vision. There is some part which is already done. The place where the scholarly community evaluates, defines, and extends what the AI proposes. So in effect, peer review for machine output, producing a knowledge base that improves itself. So already what is already running apart, the readers comment, and the text collection features a collaborative layer in use today. The community is shaping the text right now. Actually, this is the Humanitext reader, and we have launched this web application just maybe 1 week or 2 weeks ago. That's still just very early stage of development. But there are some readers already made comments about text, and then you can see these comments in this way, and then we can modify the texts themselves, and also then discussion continues and to understand better what the text means. So where it goes, so a major new initiative, this is a plan, will build this out in full. The AI proposes scholarly links between texts. So this cites that, and this critiques that, and experts verify or reject each one. And the verified result feeds back to sharpen the next proposal. This is where the loop closes. This is the color plan we are thinking about. And the last pillar is AI-ready data. The vision, the data built so that an AI can actually use it. The goal is not a prettier digital edition. Rather, it is the data that is AI-ready, structured for machine reasoning, not only for human reading. The shift, the field standard XML, which is our own, the basic and kind of building a block, but is excellent for preserving and displaying the text. But its single tree structure, XML tree structure, limits what the machine can reason over. So we can keep TI as a one authoritative source of truth and add reasoning-oriented layers on top. At the moment, we've got an archival an XML, TI XML file, and then we've got, in addition, so JSON file, which is kind of delivering the source, and both for Antigua and also reader. And lastly, layer 3, we're thinking of knowledge graph on the top of those two layers, right? So how the graph is built and why it can be trusted. So Antigua's search proposes candidate links across the whole corpus automatically, and also kind of retrieval accuracy is quite good at the moment. So scholars and students then verify or reject each one and attach the precise level. Is this a citation, a critique, an allusion, a variant reading, and so on. The verified human judgments accumulate in this way, so the graph grows in both reach and reliability. So this human-in-the-loop process is exactly what supplies pillars A and B, right? So conclusion. So one loop, not three truths. These three pillars are not separate products. They form a single cycle, and the verified knowledge graph is a keystone that links them. So basically, AI generates some answers, then humans verify those answers. Then those answers, verified answers, can be used for kind of sources, additional sources for LLMs to use, right, agents to use, right? Then those kind of pillars are based, are ultimately based on verified knowledge graphs. Okay, so what the humanities give back to AI, the contribution runs both ways. For classicists, AI philology offers tools to ask questions at corpus scale that were out of reach. So of course, keyword search was impossible to look for the look entire corpus for your kind of sources you answer. So which arguments are most contested across commentators and how an idea transforms across centuries. For AI, on the other hand, it offers a method drawn from the humanities. So how to structure genuinely interpretive and contested expert knowledge as reliable context for machine reasoning. A problem that barely arises where data is plentiful and answers are clear-cut. So basically in humanities or Western classics, not only Western classics, but in humanities, so almost all the answers are kind of contested. That's why we need some data model structures to accommodate those contestations. So what we are building toward is a working model of human-AI partnership and community-driven AI governance, grounded today in systems already in use. Okay, thank you very much. That's it from me, and then I take down to the next speaker.